Hello everyone, I'm Thomas and this is day number 30 of 100 Days of Code in IoT Challenge. Today I'm gonna show you how to make a Internet of Things device out of our motion-controlled LED strip lights that I've been building for the past 2 days. My plan for today is to use ESP8266 web server to serve some simple static HTML page with the interface and create a simple endpoint to set the color from that interface. So let's move to the Visual Studio Code. As a base, I'm gonna use yesterday's code. If you haven't watched yesterday's video and the video day before yesterday, I strongly recommend to do so. However, you don't have to, because in the description of this video, there is a link to the repository with this exact code. You can just clone it and open it with Visual Studio Code. Just make sure PlatformIO is installed. The PlatformIO extension is installed in your Visual Studio Code. Okay, so I've got main.cpp file opened already. And that's really gonna be the file we're gonna be working with mainly today. I'm not sure if I create anything else. Okay, before I begin, let me quickly remind you again what this code does. So what we've got here is 4 pins in an array, D1, D2, D5, D6, and they represent the outputs of the LED strip, right? Those outputs are red, green, blue, and white. And depending on the state that you set the digital pin to, you can have the LED strip emitting certain color of light or not, right? If you mix 2 or more colors, you will get combination of those colors. As simple as that. And also with the set color, actually, this is the function that allows you to, it just simplifies setting the color, right? It utilizes analog write to allow for setting digital pins to the value between 0 and 3.3 volts, right? It's something we can do with pulsation with analog write. And that's what it does. So you don't have to, you are not limited to just, let me think about this, I think like 6 or 8 colors. If you include white, you can have more colors, because you can set just, you know, a little blue, more red, right? No green, or like a little green, little red, and full blue. That is essentially up to you. So that's what the set color does. And in the setup function, this is where everything starts. We set all the pins to the output. And then in the loop, we do digital read on D7. This is where the output of motion sensor is connected to. So when the motion is detected, this code is going to be executed. Otherwise, we do reset, that switches the LED strip off, right? It just sets the voltage of all the outputs to 0. So there's gonna be no current in LED strip and therefore no light. Okay, if we have motion, we're setting the color to 255, 255, 255, 255. That's something we're gonna allow to be controlled from the web interface, right? Okay, so that's how it works. And now what I'm gonna do is to introduce a web server. That's something we've already done in the past. There was a video just about using ESP8266 web server. So this is gonna be a slightly simplified, I mean, I'm gonna do some copy pasting, but don't worry, I'm still gonna talk through what I'm doing and explain everything as well as I can, right? So web server include, that's the first step. And we need to initialize it like that. Okay. So that's the first step. That's what you always do. Now the next step, because web server on its own is not really gonna do anything if our ESP8266 will be disconnected from the internet. So we need to connect it to internet. And for that, I've got my own library where you can do everything in a non-blocking way. So, unfortunately, the installation is still manual. So you need to open the the command line, and then in the command line we're gonna have to change directory from the base directory of the project directory to the lib, and inside the lib git clone and the ESP8266 lib core, the library I have built, into the core folder. Okay, hopefully this is the last time, because I've got a plan to publish this as an official library on PlatformIO, in the PlatformIO library registry. Okay, so probably last time we installing it like that, but really it is just what you have to do. Then we're gonna go to core, and here it is quite important to do checkout to day 25. This is the latest code on this library, right? So having this done, we can now include some additional header files, and these are, let me show you, Wi-Fi manager, event dispatcher, and timer. Okay, event dispatcher and timer are required as dependencies of Wi-Fi manager, and essentially Wi-Fi manager allows us to connect to Wi-Fi in a non-blocking way, right? So now I'm gonna create all the instances. There's also gonna be just copy paste because we've done it before, and I need to define two constants. One is SSID, so that's the name of my Wi-Fi network, and password is the password to my Wi-Fi network, and these are passed as arguments to Wi-Fi manager along with Wi-Fi multi, pointer to Wi-Fi multi, dispatcher, and timer. And I've just realized Wi-Fi multi here is missing, so let me just add it as well. So this is ESP8266 Wi-Fi multi. Okay, so we got that as well. Cool. So that should create all the dependencies required for Wi-Fi manager. And this was really the hardest part, because now to connect to Wi-Fi, what we're gonna have to do is just as simple as doing Wi-Fi manager and calling connect method, where we pass a callback. This is a non-blocking, as I said, so a callback that takes status, and that callback will be executed once we are connected or the timeout has been reached. Okay, there is also timeout. The built-in timeout, as far as I remember, was 10 or 15 seconds. So if it doesn't manage to connect after the timeout time, it's still going to call this callback, but status is not gonna be WL connected. And if it's not gonna be like that, this is where we're gonna print something out to the serial monitor, something like could not connect to Wi-Fi, right? And we just do return, so nothing else from this function is gonna be executed. So yeah, so that is it. So that is for connecting. However, because we started using serial, I have to first go to PlatformIO.ini, and in the PlatformIO.ini we need to set a monitor speed, and that value needs to be passed to begin method on serial. So we have serial begin, and that value. Also a delay will be useful for 5 seconds, so the IDE can synchronize with ESP8266 serial monitor when it starts. Right. Okay. Let me quickly fix the code completion, because that seems like there is a small problem. Probably I need to compile everything. So let me check. And reload. Yeah, that seems like it. If it's fixed the issue with the colors of the, you see, now it's all good. Cool. Okay, so this is how we connect to Wi-Fi, but connecting to Wi-Fi on its own is not solving our problem, right? We still don't have interface. We don't have a web server really started. We just created an instance of it here. We still need to begin it. Okay, to begin it, let me show you. This is what we're gonna do. So if the status of the Wi-Fi connection is connected, okay, that was successful, we want to start the web server, right? Only if we are connected to Wi-Fi, otherwise there's not really any point in doing that, because we won't be able to access it, right? Okay, so server begin just starts web server. This is very important. It's gonna give us an address in local network, in our local network, where this server is hosted on, right? Because it's very likely that your router in your home Wi-Fi is gonna assign the IP address of ESP8266 once it connects to the internet automatically. And to get the IP address, this is required to access the website on the web server, right? To access, to actually, you know, open it in the browser. We need that IP address, and this is gonna help us, right? This information is gonna be printed in the serial monitor. Usually, once it's assigned for the first time, even if you disconnect it from the power supply, you connect it somewhere else, you may not have serial monitor at that point, you will get that information. You will get the same IP address. It is very likely. And if it's not, what we could do is to use MAX7219, the 7-segment 8-digit display, to display this information. And for that, I recommend watching another video that I've done in the past, specifically on the topic of the 7-segment 8-digit displays. But yeah, anyway, let's continue. So this just prints out the IP address that the ESP8266 has been assigned in our local Wi-Fi network. And then we use the timer. Timer is a special class I have built that, among the other features, allows us to set something on loop. And what does it mean? That means on every single iteration, every single call of this loop function, whatever callback you pass to the set on loop is gonna be called. Okay, so that means we start handling clients. Server starts handling clients. This happens in the loop, and once we are and since we are on the loop right now, there is one requirement we still have to do, but I'm working on getting rid of it, and that is timer tick. That needs to be called every single time the loop is actually like it has to be just on the loop, right? So every single time the loop is called, right? We call the tick method, and that tick method handles internally all the callbacks set on timer. So the waiting ones, or the ones set on loop, or the other ones, depending on what method you use to set them on the timer. And going with this approach, I'm thinking about getting rid of this. So we will have just timer tick in the loop, and then relying on timer to handle everything for us. And this is what I'm gonna do. This is what I'm gonna do for this if statement, if else statement. Right, so in the setup, we just set it on loop, and then we let the timer to handle it. This is just gonna be called every single time again when loop is executed. But yeah, I'll just simply move the responsibility for calling this to the timer, right? Going further, if I wanted to make this code even cleaner, what I could do is to define a function for that, and then pass just the function to set on loop, But for now, I guess this is readable enough, and we can think about this later. Okay, so we've made use of timer. We've got the server listening to the clients, right? To connections, incoming connections. Once we are connected to Wi-Fi, only once we are connected to Wi-Fi. So the next step is going to be creating an endpoint on our server, because at the moment, if we try to access our server, we just get not found as a default message, right? There is no endpoints. And I'm going to define this endpoint maybe somewhere here. So we'll have like server dot, and the way you do is on, and that is gonna be, let's say, on color. And we're gonna make use of this overload, which is taking HTTP method. And that method, let's make it put, because we're gonna be modifying the color. And then the callback function that's gonna be executed when this endpoint is hit, okay? So for that, let's think about the body of this request. What format of this body is going to be? I'm thinking about most convenient way of working with HTTP with APIs, because essentially this like how I picture this in my head, this should be just an endpoint that you can use as an API endpoint, right? Think about the REST API. And this usually, right now in the modern times, that utilizes JSON as a format of the body. And that's what I would like to do. And because we've already worked with JSON as well, I'm gonna go for JSON. That requires me to install a JSON library with PlatformIO. So let's go to quick access open, and let's install this library. Can be found here in the libraries. We just need to type in JSON. And this is Arduino JSON, which is the best library I had opportunity to work with on ESP8266. The project, which is really the Motion LED RGB, that's the name of my project, and I'm just gonna add this. So yes, okay. So I've got Arduino JSON installed. Gonna need to include it. Arduino JSON. And now with Arduino JSON, what I can do is to here read entire body. To read entire body, we done it in the past. This is how you do it. Although I'm gonna need to define the body itself, right, as a char array, so it's not gonna be very big, because I imagine this JSON as something like R and the value, right? So like something like this, then G and the value, and so on, right? RGB and W. That's how this JSON is gonna look like. So it's not gonna be very long. I think 256 bytes is even too much, but still let's keep it to be on the safe side. So we're reading this from the plane. So this is gonna read entire body, and then what we're gonna do is to use the JSON document. I think this is called static JSON document. Static JSON document. That is gonna have the same capacity. Let me call it doc. And then you do something like deserialize JSON into a document from the body. So this is gonna read the JSON body and turn it into a nice map, nice document, static JSON document, where we can access the values easily. We can do it just by, for example, if we have R, that's just gonna be R, and we can cast it as int, or as int 8, unsigned int 8, right? The byte int. this is the one that is required by the set color, right? uint8. And you know what? Let's just go with this simple example. So probably we don't even need to do explicit cast. This can be all implicit. However, I'm just thinking, calling set color in here wouldn't really do anything. We would just had a quick blip of the color, and then it would go back to what it was before. So if we did that when the motion is detected, we'd get 255, 255, 255. With no motion, it would be just a very quick, like nanosecond blip, and the LED strip would go off. So set color is not really a function to be called here, because this happens right in the loop. So that constantly changes the color, and to handle that, what I can do is to define some sort of a struct that is static, like a global variable here. So let me try to do this. You know what? I'm just gonna call it, let's just create some struct and call it maybe color. That's easy, right? So color, and that color would consist of RGB, like that, right? We would have the same type as we take in here, aren't we? And you know what? We could even in that case, oh yeah, okay, let's leave it, because it might be actually useful for other tasks, right? But this struct color, this is just definition of the struct. I still need to create an instance of it. So let's create it, and I'm just gonna do something like that. So we'll have all of these values set to 0. So that would be the default one as 0. And here, that would just do color.r, color.g, color.b, and color.w, okay? And now depends on what we set to the color, right? We will get different color when the motion is detected. But initially, because it's 0, the LED strip would be switched off, right? It stays switched off at this point. But that's why I have defined this color endpoint. So what we could do here is now, still going like with implicit cast from the document, I can do something like color.r equals doc.r, right? And the same thing I'm gonna do for RGB and W. So we'll have something like that and something like that. Okay, so that just sets it on the variable that is our struct, and then this is picked up here on the loop, right, when the motion is detected, because we want to keep the functionality of the LED strip being motion controlled, right? Yeah, but anyway, still we gonna have to respond to the client. And for responding to the client, I have already done it as well. So this is what you do. Although I need to define a content type. And our content type obviously is application JSON. Okay, so we respond with JSON, message okay. We set the color. So once we call this endpoint, once we make a request to the color endpoint from our computer, we don't see anything on the LED strip until we make a motion, right? Make a movement in front of the sensor. Then it should switch on the LED strip and it should emit a different color, right? The color that we set with the endpoint. Okay, I think what we can do right now is to do a simple test. So yeah, we can do it. I think this is pretty much, ready. So let me just deploy it. Okay, deployed. Let me connect to the serial monitor and reset. And we should get the, okay, there we go, listening on HTTP. So this is the address we are interested in. And for that, I'm simply going to open, I'm gonna copy it and open a new terminal right here. And I'm gonna use curl because it's the simplest one, right? I've actually got everything prepared here. So we're gonna set the color to R20 and G20. The put, right, this is the one that we require, the HTTP method that we require. And once I do that, and I make a motion in front of the sensor, we should see this color, which is a combination of R and G20. So it shouldn't be very bright. It shouldn't be very bright. You know what? Maybe I set W to 255, so we should see a little bit like, you know, the white brighter than the combination of red and green. Okay, and red and green is really gonna be something like a yellow, right? Okay, so I'm just gonna do it right now. We should get the response, and there we go. We've got message okay, and let's have a look at the board. Okay, so I'm gonna put my hand in front of the sensor. And as we can see, we have a yellow light and a white light at the same time. And now let me change it. Let me change this to maybe something like, maybe no white anymore. And let's set blue to maximum, to 255. Okay, and let's see what's gonna happen. Okay, I'm gonna make a motion now. And we get something in between blue and green. Right. It's actually a very nice color. And one more thing, let me show you what's gonna happen when right after the motion is detected, I change the color. So let's set it to maybe just blue. Nothing else. So just blue. And I'm gonna make a motion, and after that, I'm gonna send this request. You see, it changed right away. And this is because everything that happens here, it is non-blocking. I mean, certain internal parts of the web server, the built-in web server ESP8266, I mean the ESP8266 web server, are blocking as far as I know. But as you can see, this is all fine. It changed still like during the light being emitted. So that means the loop is simply just, you know, going on and on, right? Going on and on. There is not really much blocking of the operations happening in this loop. Nice, okay. So with that, we have a nice solution. And this sort of like could stay as it is, right? We could just make use of it and that would be nice. However, that is not my plan. That is not my plan. My plan is to also have a nice interface, okay? And for that interface, I'm going to upload an HTML file that I've prepared beforehand. Let me show you this file. I'm just gonna copy it into a data folder. And the reason I'm doing it with data folder, hang on, it's not here, it should go somewhere here. Not here, come on. yeah, data folder. This is because I wanna upload it to the flash memory of the device. And since we have done this before, like many things that I'm doing today, we've already done, but this is how programming works, right? You build the code snippets and then you reuse them in your next projects, right? So that's essentially the power of programming, and this is how I do it. So yeah, let me go to platformio.ini first, because what we're gonna have to do, since I have decided to work with the file system, we need to change it to LittleFS, because the default one is spiffs. We don't really want to use spiffs. So LittleFS is gonna be the file system, and then the data folder, I'm just gonna move the index.html file with the sliders. So yeah, to not spend too much time on this, I have done it myself before the recording of this video, but I'm gonna go through this file quickly for you to explain how everything works, right? So yeah, we have a simple HTML file, but that uses preact. Preact is like a minimal version of React. Very good for use with the microcontrollers, because it takes so little space that makes it essentially a perfect solution, right? However, in our case, the size, it's still not such a big problem, because as you probably haven't realized it, because I need to scroll it to the right. I'm actually importing it. I'm importing preact and all the dependencies required for this project from the external resource, right? So that's gonna be done. That's gonna be done from the internet. So this HTML website can only work in the network that is connected to the internet, right? So for example, if you have a network, a Wi-Fi network, and there is no internet connection, when you go to this index.html file on the microcontroller, right? So using the same address as the one I have used here in curl with this host. But yeah, obviously for your network, it's probably gonna be different, right? This bit on the IP. But yeah, if you do that, go to index.html and there is no internet on this network, this is not really gonna work, right? Because if you wanted to make it working on the local network without internet connection, then you need to download the file for the preact and put it next to the index.html data and import it from that file instead, right? But yeah, I just wanted to build something quickly, and this is the module. This is a very simple form that I've built, and let me show you. So this all starts here when we render the application. We have app component, and app component just displays a container in the center, and that container is LED control. What LED control does, this is really the stateful component. We use the state here. We've got RGBW state with all the values, all the RGB and W set to zeros. And what happens here is when this component is rendered, like when we open the site, the use effect is evaluated and it does a fetch color. Fetch color is something we don't have yet. And fetch color really does a get on our color endpoint. We don't have get at the moment, we just have put. So I'm gonna have to add it. The reason it's gonna do get is because initially we don't know, like when we refresh the page, we don't know what was the previous color, right? This website doesn't know it, right? It's some state stored on the device, right? In the memory of ESP8266. And this is gonna get that information from ESP8266, right? On the color endpoint. So this is how it works. It fetches the color and set it on the state on RGBW, and that RGBW is passed as a prop to, actually it's not even passed as a, yeah, it is passed, sorry. It is passed as a prop to the slider component. The value essentially, right? The value, and we also had set value as a function that just evaluates set color. So let me show you this component slider. We have slider for each color, right? And that slider is simply input type range. And that input type range gets the value. And when it changes, right, we call set value with the value that's it's been changed to. And that set value is really a function passed as a prop to the slider from here. From here, right? So that essentially changes the state of the RGBW, the state of the color, right? And it does it through the set color function that really overwrites the actual color, actual RGBW with the new value that we pass. And that new value is R for red, right, G for green, and so on. And then we do fetch. That should be put actually. So let me change that. And then we do the put request to set a new color, okay? If you are interested in the video where I build this thing from scratch using preact, let me know in the comments, and then I will do it and explain it step by step, because that could be confusing for some people. But yeah, when you're gonna see it in action, maybe you understand it better. So what I'm gonna do just now is to simply deploy that. To do that, we're just gonna go to project tasks, platform, and upload file system image. And that simply uploads all the files inside the data directory, which is index.html at the moment. That should be quick. Done. And once we have this done, we need to serve that file, because at the moment we have just color endpoint. We have color endpoint. We need a get endpoint for color, but give me a second, because first we need to serve a static file. And that file is going to be our, oh yeah, hang on, I'm gonna use a null pointer for now. Null pointer, and this file is really our index.html, right? So I can just do slash and slash, because that's just gonna pick up the files from the base directory, right? And this is not supposed to be null pointer, but I did it as a null pointer because I need to include little fs first. Little fs. And I'm gonna need to, in the setup function, somewhere here maybe, initialize this file system. And then, instead of passing null pointer, I'm gonna pass little fs, right? It wouldn't work with null pointer, that was just temporary. So now we serve the contents of data statically. And with this code, we should be able to see the index.html file, but now I need to add the missing color get, HTTP method get. Unfortunately, the built-in ESP8266 web server doesn't really support multiple methods when you do it like that. Like it's not possible to do something like this. Just, you know, saying like HTTP method get and so on. You can only set one listener to a single endpoint. And if you want to handle more methods, you have to do something sort of like that. So you just take any method and then what we're going to do is still we're gonna have body. Actually, no. Do we need body? No, we don't need body in both cases. So I'm gonna have switch statement for the server dot method. And then we're going to have a case for HTTP method HTTP put that ends up with break, and that is going to be the code we've got so far. But apart from that, there's gonna be another case for HTTP get. So let's do it this way. HTTP get, and for HTTP get, we want to respond with the something like let me think about that. Yeah, we need a new JSON document, so there is something really shared across. So I'm gonna define it here. We don't need it here then. And that document, you know what, because we're not sure if it's not being read before. No, actually no, because it goes out of scope, so that's fine. So we can do doc r equals color.r, right? So the other way around. So we have RGBW, G, B, and W, RGB, and W. So that's what happens first. And then we still gonna have sort of body. Yeah, I think body is still gonna be shared across, because let me show you. Here we use the body char array to read the body, right? We're gonna read it from the request. Here we want to return it as a response. So and also like for the JSON, I'm gonna serialize it now. So serialize JSON. So I'm gonna turn the document, the static JSON document, into a char array. And for that I need the doc and the destination, which is going to be our body. And then I'm gonna send that body. Okay, and the last case we want to handle is a default one, and default one really is just going to be something like invalid method, and I think that is 405 error. Okay. So if someone uses a post or patch or delete, this is just going to complain. Cool. So yeah, we've got file served statically, and we've got this get method now that should handle our HTML interface. Nice. Okay, let me deploy it and let's see what we get. Okay, serial monitor, and we should get our, yeah, so this, you see, this is the same, right? Even though I redeployed everything, we still got 192.168.0.22, right? So that doesn't change. Well, once the router allocates the IP address for the device, it stays the same, usually stays the same. But yeah, anyway, let's go to the browser now, and we check how this interface looks like. So that is gonna be this address, and this is it. It's very simple, right? We have just changed color, H1, and this, everything set to zeros, because essentially at the beginning it is 0, right? Isn't it? It is 0. So let me do green, just green to the maximum, and let's test it with the motion sensor. And we've got green. And now I'm gonna refresh the page to check if our get method is working. And we got green, right? So that works. Let me show you something interesting. So I'm gonna make a motion, and right after that, I'm going to change like the color. Maybe I add blue to it, and we see what happens. Okay. You see, we have some like a sea color, right? Something between green and blue. So you can actually change it live, right? That reacts straight away to the change, right? The color of the LED strip react straight away once you change it. This is really nice. This is really nice. Cool. So yeah, if you want, you can further improve this. Maybe add some like a nice UI, because this is as you can see, this is just bare UI, right? I didn't add any nice CSS here, just a simple HTML. Cool. Let's go back to the code, and here I actually going to add one last feature to make it perfect. Maybe not from the UI perspective though. And that feature is going to be saving the state. What do I mean by saving the state? What happens if I disconnect it from the power right now and connect it back? At the moment, it's just going to start with 0 again. So it's going to be switched off. If there is a motion, then it's not even going to switch on because of the default state of 0. I could do something about it by setting the default state to something else, like to red or green. Just pick any color, right? Or I can make use of the file system and store this information, right? Our file system is persistent, so I can store the information right after it is set on the endpoint. So once, like on the put, we set the color, we can store it as a file, can be JSON file, in the file system, and then when the device restarts, it's just going to read it from the file and load it into the memory, into our struct. So let me just do it. If we have a look at the setup function, we already initialized the file system, so that's cool. But you know what? I'm just thinking about creating a function. Maybe two functions. Let's call this config. So let's treat it as a config, okay? That's how I see it. So we can have something like read config and write config and write config. And basically, read config is gonna be the first function to be called after we initialize file system. And write config is going to be a function that is called right here, where we have the put, okay? So here we're gonna do something like write config, nice. Okay, and now what they're gonna do? So maybe we start from the write config, that's a bit easier. So for the write config, what we really want to do is to yeah, as I said, let's keep it as a JSON file, okay? So I'm going to define some const char called file name, maybe config file name, which is going to be something like, I don't know, maybe config.json, right? If we decided to go for JSON, let's just do config.json. And for that, simply I can create, open, sorry, little fs, open the file, config file name for writing, because we're gonna be writing to it. The format we're gonna have to write to the file is a simple C string. It can be C string or just string, but the problem is, at this point here, we just have the struct. We don't really have a JSON, right? We just have this struct, color, and we're gonna have to sort of like change it into JSON. But this has been done already here. So if you have a look, that is the serialized JSON, this bit of code, right? When I'm just doing it, I already feel uncomfortable. You know why? because I'm doing copy paste and I don't like copy paste the code like that. I don't like to have duplicates, the code duplications. So right away, you know what I'm gonna do? I'm actually going to do something like, let me think about this. We can either extract it into a separate function, or actually we could extend the struct. We could turn it into class and add the serialized JSON and like, you know, like to JSON and from JSON methods. And that would handle also this bit. That is probably gonna be useful for the other function to read the config, you know? Let me show you what I mean. So I'm gonna go to the struct and I'm gonna turn it into class. And this all gonna still be public. So this is gonna be sort of struct with some, this is really, from my perspective, this is still gonna be a data structure, but with two helper methods. One helper method that I'm thinking about is going to be from JSON string. And that from JSON string will take const char. And here, this is going to happen. So that's what we got here, right? So we're gonna have the static JSON document. Okay. And deserialized JSON and this bit, right? This is when we're reading. So we could have that. But instead of color.rgb, we can use this pointer. Cool. Yeah, so and instead of body, obviously we're gonna have a JSON string, right? So yeah, when you call this, it's just going to read all the JSON string const char variable, and it's essentially going to deserialize it to JSON, right? To the statically created JSON document, just for the sake of this method. But because we're gonna do this copy into these members of the color, this is all going to stay, right? So this is just temporary, but that's gonna stay as it is, right? So that's how we read from the JSON string, right? However, that has to be JSON string. And the second method that I'm thinking about is to JSON string, right? So we're gonna have something like to JSON string. And this time I'm more thinking about something that is again taking but buffer, right? So we'll have something like buffer, and we're gonna be writing to that buffer. For that, what we need to do is to create a JSON string 256. I can actually create a constant for that. We can just, you know, because it's too many 256, we could split it out and create a constant for this, like a JSON size. I'm not gonna do it, it's just a suggestion if you work with this code. Or, you know what, I'm gonna do it. And we're just gonna use JSON size everywhere. We're gonna get rid of the JSON document from here, so I'm not gonna change there. Right, so we will have the JSON string char array with the same size, okay? And now we need a static JSON document as well. We're going to do the other way around. So this is what we done here, right? So let me copy this. But again, I'm gonna have to change the color to this pointer. Like that. Nice. And as I have done deserialized JSON here, in the from JSON, here, I'm gonna have to do serialized JSON. And that takes the document. Sorry, is it document? This is a document, yeah, and destination is going to be JSON string. At the end, we're going to copy this JSON string into buffer. So what's gonna happen here is essentially the same thing happens here, right? It happens at this point. And you know what? With that approach, we can keep the body. We don't need static JSON document. Because what I could do here right now is to just use color dot, and that will be from JSON string, and our from JSON string, what we need to pass as an argument is the body, because the body is supposed to be a JSON string. And then in the get method, for the get method, instead of doing all this serialization, what I could do is again run color dot to JSON string and pass the body. That's gonna be the buffer it will write to. So we can send the body in the response, right? So that actually simplifies it. So now we have the responsibility for converting the color struct into JSON, or creating it from JSON is moved now to the struct. To be honest, we could go even one step further and make this we could make it one of the constructors, right? This could be a constructor where you just pass JSON string and it's gonna construct this object for you. But because we use it statically, I think I'm just gonna stop here, keep it like it is, and now move to our read and write config. Write, because this is what we started. And now with the write config, this is gonna be pretty straightforward, because to write config, what I'm gonna have to do is to define a body. Let's use the JSON size. We need the body of the file. I mean, maybe I don't call it body, but just content. And then just call toJSON string on the content. So the content now is going to be JSON string, and we can easily do file write and content. File close. And error handling from the file as well, which is going to be here, right? It is quite useful to have it. So if we cannot open the file for write, I'm going to print this information, could not open config file for write, and that's just gonna return, so stop execution. Cool, so write config is done, and read config is really gonna be other way around operation. So this I can copy paste. However, again, we could really, yeah, okay. I allow it. I allow it now. We can have the duplication, because I spent quite a lot of time already on this, so I'm just going to, like, you know, finish it as quickly as possible, and that would require some thinking how to arrange the code in a way to to have less duplication, because like this clearly could be abstracted out somehow, but not today. Not today. I might refactor it further, maybe not tomorrow, but like in 10 days or something. Especially if there is an interest about this particular project, improving it, I could add some extra features, and then there's gonna be time to do a little refactoring on it. But for now, I guess this is fine. Right, so read config. Again, we want to read the file now, because we know the file is not big. We just store there just JSON information on RGB and W. We can do a simple read. A simple read that just uses string, Arduino string, content, and that equals file dot read string, right? That's gonna give us string. We get entire content, and then what I can just do is to do color and from JSON string. And you know what? I don't actually need a content variable, because I can pass file read string straight away and file close once we've done it. Okay, so this is it. This is essentially it for reading and writing the config. And I'm gonna do one final test, and we've got this whole solution ready. But before I do that, let me quickly go through everything again, just quickly, not much explanation. So let's go to a setup. Okay, so setup, this is where everything starts. This is initialization. We're reading the config. So reading the config essentially checks if there is a file, right? It tries to open the file. It is here. config.json. And if the file is there and can be opened, we just read its contents into a color, which is a statically created object, right? More like a struct, really, data structure, right? Color. And that color from JSON string method simply creates a static JSON document, deserialize it from the given JSON string, and assigns its values into RGBW class members on the color. So we can access RGBW, for example, in this loop callback, right? This loop function. And this is the core functionality of this project, which is basically checking where the motion is detected. And when it's detected, we just set the color to whatever we have inside this color struct that is this is essentially assigned to this variable and statically declared here in the main.cpp. Okay, so that's how this read config works. This is just setting the pin modes for all the channels RGBW to output, and we have endpoint color handles two methods: put, that is reading the body, and essentially it's reading it from JSON and loading into our color object. After that, writes the config, right? So we write here, we open the file for writing. If it doesn't exist, it's gonna create it. And this content essentially is going to be a JSON string that we write to the file, and we close the file, right? So this is whenever this is changed with the HTTP put method on the color endpoint, we write the config, right? So if the power is if we switch off the power, right? Stop the power supply from ESP8266, connect the power back, it's gonna retain the same color on the LED strip when the motion is detected, right? So that's for the write config. And the get method is essentially doing the other way around operation, right? So we read the color, right? We read the color and the RGBW members on the color class and we turn it into a JSON, right? That we save it, we write to the body, and then we just send it back in a response. So if someone does get, we just say, yeah, this is the state of the RGBW LED strip lights, right? This is what the color we have set. The default really is for the all other methods which are invalid. So we just send an error. This is to serve index.html statically. This is our web interface, right? And here we just got the logic to connect to Wi-Fi, and only when we are connected to Wi-Fi it actually starts the server and starts handling incoming connections. And this is, I've already explained, just the core functionality, checking if the motion is detected, and if it is, setting the color using the values from the color object, right? In the loop timer tick, this is just to handle all of this callbacks that we set on the loop, for example, and all the other non-blocking operations happening in the Wi-Fi manager connect. Cool. Okay, so let's deploy this now and let's see the final results. We've got an error, and this is due to the fact that I have missed something. Let me show you what it is. From JSON string takes const char pointer, not a string, and that can be fixed easily by doing .cstring, right? That's gonna convert a string to a C string, and now that should compile up. Okay, still an issue. I think this is probably on the right. Again, another thing I have missed. Sorry about that. This is here where we write the content, and I think the reason simply is that we need to cast it explicitly into const char. Also, quick note before you deploy, I have made another mistake. It's a logical mistake. And it's here, right? That should be other way around, because we really want to write into the buffer, not to the JSON string. So that's what we want to do here, okay? Okay, so let's finally test it. Okay, as we can see, it could not open config file for read, and this is correct because file doesn't exist yet. And we're listening on the 192.168.0.22, so that hasn't changed, right? And now, when I make a motion, we won't get anything. So as you can see, all the color channels set to 0. And now, I'm gonna open our web interface. You see, everything is on 0, right? So let's set red. Now a quick test with the motion sensor. So yeah, red is working. And now let's do a quick refresh. Okay, we still got red, right? So that part works. Let's have a look at the serial monitor. Okay, we don't have anything. We don't have any problem with write. So you know what I'm gonna do? I'm gonna press reset and let's see what is going to happen. We should get red after I make some motion, okay? So gonna do reset. Okay, listening again. And now let me refresh this page. And we still get red, right? So that essentially works. One more test. Let's do red maybe and blue. Let's check this color. Okay, we have a nice purple. And now I'm going to completely disconnect ESP8266 from USB for a few seconds. So there is no power now, except for the motion sensor, because we don't really want to wait for the synchronization 1 more minute. And it doesn't really interfere with ESP8266. Okay, let's connect it back. Connect it, and let's see if we get purple now. There we go. So as you can see, this all works well, and that essentially concludes the solution, right? Obviously, that project could be improved further. There is actually many possibilities, many things we could add to it, right? We could start collect some data on when the motion has been detected, right? So like collect data on waking up time or going to sleep time. I could add a light sensor to reduce power consumption. So this LED strip lights would switch on only if it's dark in the room. We could add another sensor on the other side of the bed, right? Because at the moment it works on one side. For another side, we need another sensor. So we could either buy very long wires and connect the sensor using these wires, right? We would put it on the other side of the bed. Or, for example, we could use another ESP8266, connect the sensor there, and then make it communicate with the first board, right? And then make the LED strip switching on when the motion is detected on the other side, right? So yeah, it's many possibilities. And if you're interested in that, if you would like me to make a video about further improving on a very specific subject, right? Very specific improvement you would like me to do on the video, step by step, let me know in the comments and I will do it for you, because yeah, I'll be happy for that. I'm gonna start actually using this in my bedroom right now. So it's gonna stay there, and maybe if I have some time, I do some improvements myself. Cool. From tomorrow, we're gonna go back to software for a few videos, because I would like to finally consolidate all the code and all the knowledge about the IoT communication. So things like HTTP client, HTTP server, time synchronization, all these things we've done during the refactoring sessions, right? So things like timer, things like even dispatcher, right? I would like to put them together and publish them as a PlatformIO library. So we would have a nice set of tools to be used in the future, more complex projects, because for the future I plan much more complex projects than this one. Cool. If you like my content and you would like to stay up to date with my channel, click on the subscribe button below so you will get notified as soon as I upload the next video. Thanks for watching and see you tomorrow.